What lies beneath Jupiter's swirling clouds isn't what scientists expected. In fact, the further we look into the gas giant, the more it begins to resemble something entirely alien. Not just foreign to our understanding of planetary physics, but possibly foreign to the very principles of nature as we know them. Beneath its colorful bands and chaotic storms may rest an artifact, something ancient, manufactured, and not of Earth. Jupiter has always captivated astronomers, ever since Galileo first pointed his telescope toward the night sky and saw its moons dancing around it. But despite centuries of observation, Jupiter remained largely a mystery. A planet without a solid surface, cloaked in violent winds and layers of thick, opaque gases. For a long time, we believed it was just a ball of hydrogen and helium, a failed star with no secrets to hide. That illusion began to fracture when NASA's Juno spacecraft entered Jupiter's orbit in 2016. Unlike its predecessors, Juno wasn't just taking pictures. It was diving deep, mapping gravity, measuring magnetic fields, penetrating the clouds with microwave sensors. And with every orbit, it sent back data that didn't just surprise scientists. It unsettled them. Beneath Jupiter's gaseous shroud, the core wasn't solid. It wasn't even dense in the way they had predicted. The gravitational readings showed something disturbing. The planet's core seemed diluted, diffused, as if it had been violently disrupted or constructed. That wasn't supposed to happen in a planet this size. Traditional models said Jupiter formed from the solar nebula, gradually pulling gas toward a rocky center. Over time, gravity should have compressed the core into something heavy, hot, compact. But what Juno found was a sprawling region of partially dissolved material, spread wider than expected, with no clear boundary between core and envelope. And then there was the magnetosphere, one of the largest in the solar system. Jupiter's magnetic field is 14 times stronger than Earth's. But it wasn't uniform. Juno detected strange lopsided regions, including a magnetic anomaly near the planet's equator dubbed the Great Blue Spot. It pulsed and rotated at an odd rhythm, completely unrelated to the expected patterns of convection and motion. It was almost deliberate. To understand what might be buried at Jupiter's heart, we must begin by peering past its clouds, through layers of ammonia and water vapor, into the storm systems that stretch thousands of kilometers across, through the Great Red Spot, a hurricane so vast it could swallow Earth whole, and yet stable enough to last for centuries. Beneath that chaos lies a zone scientists call the metallic hydrogen layer, where pressures are so intense that hydrogen atoms lose their electrons and form a strange, conductive fluid. This layer is what powers Jupiter's magnetic field. But even that doesn't account for the field's complexity. In places, the field lines twist in unexpected directions, as if distorted by something massive, hidden deep within. By 2019, Juno had completed dozens of orbits. The more gravitational data it collected, the less consistent Jupiter's interior appeared with the models we trusted for decades. Some scientists suggested a collision, that perhaps billions of years ago, a protoplanet slammed into Jupiter, disrupting its core. But the theory had problems. The energy from such an impact would have left detectable traces on the surface. And there were none. The chemical composition didn't match. The symmetry of the outer cloud layers didn't support it. Something else had disrupted Jupiter's core, something from within. But why would a core be hollowed out? Why would dense materials appear to be suspended, not compacted? Why were there structures of varied density that looked more like layers than gradients? This was when the whispers began. A few fringe researchers, previously dismissed by mainstream journals, re-entered the conversation. They began asking, what if we're not looking at a failed star? What if we're looking at a shell? What if, beneath Jupiter's dense clouds and metallic hydrogen, there exists something engineered? A construct so vast and ancient that it has masqueraded as a planet for billions of years? At first, it was dismissed as speculation, pseudoscience. But the data didn't go away, and the anomalies kept stacking. Radio emissions from Jupiter have long puzzled scientists. The planet emits powerful bursts of radio waves, some originating deep within its interior. These bursts don't follow the patterns of natural emissions. Their timing and frequency sometimes shift abruptly. When researchers applied Fourier analysis to long-term radio observations, they found something they couldn't explain: harmonic frequencies, stable, repeating patterns that seemed too orderly. The obvious explanation, natural resonance from spinning plasma or interacting magnetic fields, was proposed. But it didn't hold up under scrutiny. The strength of the signal was disproportionate to the known sources. The harmonics didn't drift the way thermal patterns normally do. Some researchers quietly noted that the signal had qualities similar to modulated carrier waves used in artificial communication systems. Still, the idea of an alien artifact the size of Jupiter's core was too outrageous for peer-reviewed journals, so it remained in the margins, talked about on late-night science podcasts or embedded in speculative fiction. Yet every year, more data emerged that made the question harder to ignore. Why does Jupiter's core behave like a stabilized field generator? Why are there geometric anomalies in the magnetic map? Why do some gravitational signatures suggest internal structures with sharp boundaries, when natural planetary formation always produces smooth gradients? To answer those questions, we have to go back, not just to Juno, but to the early 2000s, when researchers first noticed the density dip problem. Using ground-based Doppler spectroscopy and infrared telescopes, scientists studying Jupiter's limb detected inconsistent pressure gradients. These findings were too subtle for Voyager or Galileo to detect, but they implied that something massive and non-gaseous might be influencing the surrounding fluid dynamics. That something was located deep beneath the surface, too deep to image, too shielded to scan directly. And yet its presence rippled outward, like a massive object hidden beneath the surface of a lake. Only instead of water, it was buried under 20,000 kilometers of pressurized gas. When Juno began mapping those anomalies, it confirmed a disturbing truth. The gravitational map of Jupiter wasn't symmetrical. It had lumps, irregularities, areas of concentrated mass, encased in lighter material. The shape didn't match any known planetary model, but it did resemble something else, the internal layout of a megastructure, a concept long theorized in astrophysics but never observed. And the more data we gathered, the more the anomaly at the center of Jupiter looked like a hollowed cavity surrounded by shells of denser material, not formed naturally, but arranged, reinforced. For centuries, Jupiter has acted like a shield. Its immense gravity deflects comets, its magnetic field sweeps away cosmic radiation. In many ways, it protects the inner solar system, including Earth. But what if that's not a coincidence? What if its role wasn't just incidental? What if it was placed there? The concept is radical, but not without precedent. Ancient alien theorists have long speculated that intelligent civilizations might construct Dyson spheres or stellar-scale machines for purposes we can't comprehend. Jupiter wouldn't be a full Dyson sphere, not orbiting a star, not hollow throughout, but as a disguised probe, an ancient archive, or even a long dormant vessel. The idea isn't impossible, just terrifying. What's more terrifying is the possibility that we've been orbiting such a construct for our entire existence without ever knowing. And if Jupiter is artificial or partially so, then the question becomes, who built it? And why? That question has haunted scientists and theorists alike for years. And the search for answers begins not with Jupiter's swirling storms, but with the signals hidden beneath them, in a place no probe has yet reached. But Juno is getting closer. The first time scientists saw the data, they assumed it was a mistake. Instruments fail. Software glitches. Cosmic rays interfere with sensors. But none of those explanations held up when the readings were replicated again and again. What Juno was detecting beneath Jupiter's outer atmosphere wasn't noise, it was an anomaly. One that kept growing more complex with every orbit. The anomaly was magnetic. More precisely, it was a localized distortion in Jupiter's massive magnetic field, one that rotated slower than the rest of the planet, and that shifted slightly over time, behaving less like a naturally generated magnetosphere and more like an independent source embedded deep within. They called it the Great Blue Spot. While Jupiter's Great Red Spot had long been known as a surface storm, the blue spot was different. It wasn't visible in traditional imaging. It only appeared on magnetometric and microwave scans, and its behavior didn't match any convection model. Rather than being tied to the dynamics of the surrounding gases, it seemed anchored to something beneath them. In planetary science, such anchoring is nearly impossible without a fixed surface. But Jupiter doesn't have one, at least, not in the traditional sense. Which raised a new question. What, then, was holding this anomaly in place? Over time, Juno's orbital path shifted to allow closer passes over the equatorial region, where the anomaly was strongest. The data it returned showed strange harmonics in the magnetic field. Normally, a magnetic dipole, like Earth's, will have two dominant poles. But Jupiter's field showed distortions suggestive of higher-order harmonics, almost as if it were being manipulated by engineered structures buried within the planet's depths. Then came the infrared scans. Though Jupiter's surface is opaque to visible light, long-wavelength infrared sensors can detect heat signatures emanating from its deeper layers. What the instrument saw beneath the region of the magnetic anomaly was a zone of extreme thermal contrast, a sharp boundary between areas of high energy emission and cooler surrounding material. Some researchers proposed that the anomaly was due to a massive upwelling of material from the core. But again, the shape was wrong. Upwellings follow plume-like paths, chaotic, branching, and unstable. What was detected looked more like a column. A heat pillar, perfectly vertical, perfectly stable, and, according to one model, encased in a sheath of superconductive plasma. The moment those findings were published in an internal NASA white paper, speculation exploded behind closed doors. Because such a structure had no analog in planetary physics. Because such a structure looked intentional. Independent researchers began digging through older data, observations from Earth-based radio telescopes, archives from Voyager, Galileo, even Pioneer 10. What they found was chilling. The anomaly wasn't new. It had been there for decades, maybe longer, but had been dismissed or misclassified. In 1992, a minor paper had noted strange, delayed modulations in Jupiter's low-frequency radio bursts. These delays seemed to cluster around certain rotational phases that, when plotted against Juno's recent data, aligned almost exactly with the current location of the Great Blue Spot. It was a signal hiding in plain sight. But what kind of signal? When engineers ran the waveform through audio synthesis models, they found something strange. The frequency clusters showed spacing consistent with harmonic communication bands, not unlike spread spectrum signals used in advanced radio systems. There were dips, pauses, even recursive chirps, patterns not typically found in thermal emission spectra. Of course, there were alternate explanations. Plasma instabilities, nonlinear feedback in the ionosphere. But each time a new explanation was offered, new data emerged that poked holes in it. And slowly, the idea that Jupiter might be more than a planet began to gain traction. If we accept the possibility, even hypothetically, that some aspect of Jupiter was constructed, then the magnetic anomaly isn't a side effect. It's a signature, a beacon, and it isn't the only one. Other anomalies, once thought isolated, began to appear connected. Juno's gravity science instrument, which uses Doppler shifts to map Jupiter's mass distribution, began detecting micro-deviations in acceleration during its Peryhove passes. At first, these deviations were dismissed as turbulence. But they repeated, always in the same orbital sector, always with the same periodicity. This suggested something massive, dense, and localized, perhaps even layered. When the data was run through a simulation, researchers found something astonishing. The model that best matched the observations wasn't a naturally stratified core, but a nested structure, concentric shells of differing density, with gaps between them. Some began calling it the onion model. But unlike a natural core, whose density increases smoothly toward the center, this structure had discontinuities, jumps in density that matched geometric ratios. Like engineered layers. The notion was unpublishable in mainstream journals. But in internal circles, the debate grew. If this was an artifact, how old was it? Who made it? And for what purpose? There were no direct answers. But comparative studies offered hints. In the 1980s, SETI researchers explored the concept of long-term information repositories, ancient libraries scattered throughout the galaxy by intelligent civilizations. These structures, if real, would need to survive billions of years. And the best protection against entropy? A planetary-scale shell. Or better yet, a planet itself. Not a vessel floating through space, but a construct hidden within a gas giant, its presence masked by atmospheric storms and magnetic chaos. A perfect hiding place. Invisible to optics. Inaccessible to primitive probes. Was Jupiter such a construct? And if it was, how could we tell? This is where things take a more speculative turn. One fringe theorist proposed a chilling hypothesis. The anomaly isn't just an artifact. It's a sensor array. A watcher. According to this model, the magnetic patterns aren't emissions, but reflections. Jupiter is listening to Earth, to our satellites, to our probes. And when we reached a certain technological threshold, it began responding. It's a bold idea, one that treads close to science fiction. But the evidence, however circumstantial, keeps piling up. Let's return to the magnetosphere. In 2020, a sudden fluctuation in the magnetotail, the region extending away from the Sun, was detected. The tail twisted, briefly, by several degrees. This shouldn't happen in a stable system. Yet the event coincided with an unusually strong burst of radioactivity, one that bore spectral similarities to Earth-based radar. The possibility was raised. Had our own deep space transmissions triggered a response? Again, speculative, but not impossible. Even more unsettling were the gravitational echoes. In late 2021, Juno detected what appeared to be a faint gravitational wave, a ripple, during one of its closest passes. Such waves are usually cosmic in origin, caused by black hole mergers or neutron star collisions. But this wave was localized. It didn't match any distant event cataloged by LIGO or Virgo. The signal was short, focused, and seemed to emanate from within Jupiter itself. If true, it suggests not just mass, but motion, deliberate movement, deep in the core. And if something that massive is moving, then it's active. We have no current models for what kind of mechanism could generate a detectable gravitational pulse from inside a gas giant. No natural process could localize that much energy. Which leaves us with one conclusion. Something deep inside Jupiter might have just stirred. And perhaps it's been waiting, dormant, observing, until now. The idea that Jupiter's core might be an ancient alien artifact is not just about a magnetic anomaly or a thermal oddity, it's about form, geometry, architecture. When scientists and theorists began comparing the internal structures inferred from Juno's data with patterns found in known artificial systems, something remarkable surfaced: symmetry. Not perfect symmetry, but structured consistency. The kind nature rarely produces without purpose. In engineering, especially on macro scales, certain design principles repeat: stress-bearing shells, redundant layers, radial distribution of mass. These are principles found in everything from human-built reactors to theoretical megastructures. And in Jupiter's core models, especially those based on gravity mapping simulations, some of these same configurations appeared. Too subtle for direct imaging, but visible in density gradients, in the way energy flowed through layers, and in the electromagnetic feedback radiating outward. One of the most striking features was what researchers nicknamed the halo, a toroidal ring of anomalous density surrounding a lower mass center. This shouldn't exist in a natural planetary core. Under normal formation, pressure compresses material toward the center, forming an ultradense heart. But in Jupiter, the densest region was offset, distributed in a ring-like formation tens of thousands of kilometers across. This prompted some to compare it to fusion reactor designs, specifically toroidal confinement systems like the tokamak, a ring of conductive plasma, suspended in magnetic fields, channeling energy through controlled flows. Could such a configuration exist inside a planet? And if so, who would build it and why? Further investigation brought more disturbing parallels. At the heart of the halo, simulations suggested a void, a lower-density region surrounded by denser material. This wasn't an empty space, per se, but a chamber, a pocket. Its properties were hard to model, but its presence remained consistent across multiple datasets. Some speculated it could be an energy sink, a storage zone for radiation, or even data. Others believed it might be a control chamber, shielded by layers of exotic matter. But the most radical idea was this: that it was a relic, a technological core, an archive, or a beacon, dormant for eons. To explore this further, researchers turned to comparative mythologies. Across Earth's cultures, Jupiter, or its equivalents, was often portrayed as a divine watcher. Zeus, Marduk, Thor, sky kings, thunderers, beings associated with power, storms, and judgment. Coincidence? Possibly. But some ancient alien theorists suggested it wasn't. They argued that if a civilization had seeded knowledge across planets, leaving beacons or constructs behind, then perhaps Earth's earliest societies had glimpsed, literally or metaphorically, traces of their presence. The brilliance of Jupiter in the night sky, its massive storms visible to early stargazers, could have become mythologized. But what if the myths were memories? Distorted echoes of contact long forgotten? It's a controversial line of thought, but it gains traction when paired with hard data. One of the most compelling pieces came from a study comparing Jupiter's radio emissions to certain rhythmic phenomena found in brainwave patterns. At first, this sounded absurd, but the analysis was mathematical. Researchers examined the temporal structure of low-frequency pulses emitted by the gas giant, then compared them to phase-locked loop systems used in neural synchronization. Surprisingly, the match was significant. Not in content, of course, but in form. The radio waves followed patterns of repetition, delay, and reinforcement that mimicked the logic of sensory encoding. In other words, the emissions looked like they were designed to be received. not merely broadcast. This led to a new question. Is Jupiter trying to communicate? If so, with whom? We know that Earth-based antennas occasionally capture bursts from Jupiter, especially during certain alignments. Most are considered natural. But over the past 2 decades, a small number of anomalous pulses have been logged. These pulses, when decoded via modulation analysis, show amplitude patterns that resemble prime number sequences, an idea long theorized as a potential format for interstellar communication. It's impossible to say whether this is deliberate or coincidence. But one thing is clear: Jupiter is not a passive body. Its emissions fluctuate in ways that suggest responsiveness. During solar flares, its outputs change, not just in intensity, but in pattern. During lunar alignments, its magnetosphere distorts. And during Paraho flybys, Juno records subtle shifts in frequency. All of this leads back to a central thesis: that something inside Jupiter is listening, reacting, and perhaps remembering. What would such a structure be made of? Traditional materials couldn't survive such pressure. The environment near Jupiter's core reaches hundreds of gigapascals, with temperatures exceeding 20,000 degrees Celsius. No known alloy or composite could endure that. But in theoretical physics, there are materials we haven't yet created. Metastable quark matter, degenerate neutronium, lattice-phase dark matter. These sound like science fiction, but they're grounded in real equations. Materials that only form under stellar conditions, and that could, in theory, be shaped, structured, and maintained. If an ancient civilization, millions or billions of years more advanced than us, had such technology, constructing a fortress beneath Jupiter's clouds wouldn't just be possible. It might be ideal, shielded from radiation, impact, and time itself. There's another possibility. Some have proposed that Jupiter didn't just form around the artifact, but that the artifact formed Jupiter. That at its center lies a seed, a device of unknown origin, that began accreting mass in the early solar system, drawing gas and dust around itself until it became a world. In this model, the planet is the artifact's camouflage, a self-building fortress, a protective shroud. And the artifact? Perhaps it's not dormant at all. Some speculate that it's a relay station, a node in a galactic network. Others believe it's a memory core, storing the history of an ancient species, waiting for the right intelligence to find it. But one particularly haunting theory suggests it's a contingency plan, that if a certain threshold is reached, if humanity crosses a line, the core will awaken, not to attack, but to observe, to assess, or to decide. This takes us far from science into the realm of speculation. But remember, every technological revolution was once fantasy. Radio, satellites, probes, AI. If we're seeing the fingerprints of intelligence in Jupiter's heart, it wouldn't be the first time the impossible became real. And perhaps we were never meant to find it so soon. Because while we send probes into space and listen for distant signals, perhaps the signal was here all along, hiding in the swirling depths of a giant. Waiting, watching, and now that we've begun to understand, it's listening back. In the quiet halls of research institutes, behind closed-door meetings and password-protected folders, a strange divide began to grow. It wasn't just about data anymore, it was about belief. About how far scientists were willing to go to explain the unexplained. While some clung to traditional planetary formation models, others, once silenced by the weight of orthodoxy, began to speak again. Their voices, long confined to footnotes and fringe journals, suddenly found new relevance. These were the thinkers on the edge: astrophysicists, plasma specialists, radio engineers, and cosmologists who had once suggested that not all structures in the universe formed naturally, that the line between physics and intention could sometimes blur, and that Jupiter, long considered a stabilizing monolith of the solar system, might be something more, something hidden in plain sight. Their hypothesis was simple in essence, but staggering in implication. Jupiter's core is not just unusual. It's not just a disrupted region of hydrogen and helium. It may be a device, a construct, an artificial body surrounded by organic-looking chaos to avoid detection. But they were not unanimous. One faction, based primarily in Northern Europe, believed the anomaly to be a relic, a dormant library of sorts. Their argument was founded on spectral analyses showing that some of Jupiter's radio emissions were not just random bursts, but highly organized frequency clusters. These clusters exhibited time signatures that aligned, uncannily, with known celestial events, including Earth's solstices and lunar phases. To them, this was more than coincidence. It was memory, calibration, a system designed to monitor multiple celestial bodies, tracking patterns across eons. Another group, led by a cohort of cosmologists in Japan and Chile, took a more provocative stance. They believed the artifact to be active, not hostile, not invasive, but watching, listening, perhaps even learning. Their evidence came from simulations run with machine learning models. These models were trained on Jupiter's emissions over decades and then asked to predict future output patterns. The result? The AI models failed, repeatedly. Unlike natural processes, which generally follow probabilistic behavior, Jupiter's emissions responded to change. Slightly, subtly, but consistently. In one particularly revealing test, the model predicted a drop in low-frequency emissions during solar minimum. What actually occurred was the opposite, a sharp spike in radioactivity. It was as though Jupiter compensated for the sun's silence. Not by chance, but by design. Then came the dissenters. Prominent planetary scientists called the artifact theory irresponsible. They pointed out that data could be misread, patterns overinterpreted. After all, human cognition is wired to seek order in chaos. Faces in clouds, signals and noise. They warned that fringe theories often stemmed from confirmation bias, and that extraordinary claims require extraordinary evidence. But even these skeptics could not fully explain certain features. Why, for instance, did Jupiter's inner magnetic field remain misaligned with its rotational axis, unlike any other planet? Why were there recurring pulses of high-energy particles that aligned with no known solar or galactic event? Why did gravitational mapping show concentric mass rings, inconsistent with standard formation models? Some tried to fit these anomalies into collision models, positing that Jupiter had once absorbed a rogue planet. Others proposed exotic core erosion mechanisms, unseen elsewhere in the solar system, that invoked only here. But such models became increasingly complex, stacking assumptions upon assumptions just to preserve a natural explanation. And all the while, the voices on the fringe grew bolder. They pointed to Fermi's paradox. If intelligent life is common, where is everyone? Perhaps, they said, we've been looking in the wrong direction, waiting for a message when the messenger was already here. Camouflaged, embedded, orbiting the sun for billions of years. Enter the artifact hypothesis. This theory, while radical, gained traction in interdisciplinary circles. It proposed that advanced civilizations, long gone or merely distant, seeded observational artifacts throughout the galaxy. These constructs would be passive, meant not to interfere, but to record, to observe. Some might awaken if provoked. Others might transmit only when intelligent life approached a certain threshold. According to this model, the anomaly within Jupiter could be one such seed, protected by layers of gas and magnetic interference. Too deep to probe, too stable to decay. Built to last. What disturbed some was the possibility that the artifact might not be alone. That other gas giants, Saturn, Uranus, Neptune, might hold similar secrets. That our entire solar system could be a testbed, a node in a vast, silent web. Within NASA, ESA, and JAXA, this idea remained unspoken in public. But internal memos began circulating. Explore increased infrared scanning near-core models. Prioritize telemetry cross-checks with gravitational anomalies. The language was clinical, precise. But behind the words was a quiet urgency. Even private firms joined the search. SpaceX, Blue Origin, and smaller startups began investing in long-range sensor platforms. Publicly, they cited research into magnetic propulsion and atmospheric composition. But the real reason was harder to pinpoint. Some speculated that leaks from academic sources had stirred curiosity. Others believed these companies had detected anomalies of their own, through satellite drift, unexplained signal reflection, or telemetry gaps. In 2023, an anonymous whistleblower claimed that a commercial satellite experienced magnetic inversion while near Jupiter's magnetotail, a phenomenon not recorded anywhere else in the solar system. The satellite's guidance system failed briefly, its gyroscope spun out of sync, and when it resumed function, it had logged a spike in low-frequency EM noise. The data, later released in part, showed repeating tones that matched the radio pulses logged by ground stations years before. Coincidence? Maybe. But patterns like these began to accumulate. By 2024, A new wave of academic papers emerged, not claiming the artifact theory was fact, but acknowledging its possibility. Peer-reviewed studies began to explore the idea of non-natural interior configurations. Others modeled deliberate density partitioning in gas giants. No one dared use the word artifact in a title, but the implication was clear. Still, resistance remained strong. The scientific method is built on skepticism, and rightly so. The artifact theory sits at the edge of plausibility. It lacks direct observation. It lacks physical samples. But what it does have is the weight of pattern. Patterns that continue to echo across instruments, years, and theories. And in science, echo matters. For now, Jupiter remains shrouded in its layers of metallic hydrogen and ammonia storms. Juno continues to orbit. Observatories continue to listen. And somewhere in that vast, roiling sphere, a structure, ancient, silent, patient, may be listening back. It doesn't blink. It doesn't move. But it hums. Not a song. Not a message. Just presence. Waiting for someone, something to understand. What if it's not a planet? That question, once whispered on fringe forums and speculative panels, now lingers in the minds of even the most hardened skeptics. It's no longer just the anomalies in gravitational data or the harmonics in radio emissions. It's the collective accumulation of unanswered questions, layered atop one another, like strata beneath a planet that might not be a planet at all. When you look at Jupiter through a telescope, what do you see? A swirling marble of gas and storm. A massive protector of the inner solar system. A failed star. That's what textbooks tell us. But let's step back from assumptions and examine this object for what it is, a behemoth of magnetic strength, rotational speed, thermal output, and energy storage, behaving in ways that increasingly define natural categorization. Take, for instance, the matter of angular momentum. Jupiter holds the vast majority of the angular momentum in the solar system, more than all other planets combined. It spins at breakneck speed, completing a full rotation in under 10 hours. But what's most confounding is that this spin doesn't slow down. Not appreciably. Not as expected. Despite its storms, its heat loss, its complex magnetic interactions, Jupiter's rotation remains unusually stable. Like a flywheel engineered to run for billions of years without friction. Now consider energy. Jupiter emits more energy than it receives from the Sun. This is well documented. It radiates infrared heat into space from deep within its interior. The standard explanation is residual heat from its formation. But the numbers don't add up. Jupiter is over 4.5 billion years old, more than enough time to cool. Yet it continues to burn with interior warmth. Not a flicker, but a sustained glow. Could something be generating that energy? Not in the sense of a fusion core. Jupiter's mass isn't sufficient for that. But perhaps in the way a reactor dissipates heat. A controlled process. A cycle. Thermodynamics would require a source, material undergoing change, entropy being managed, perhaps even harvested. And then, there is time. Time in a geological sense. Time in the cosmic context. If an advanced civilization wanted to send a message, or preserve knowledge, or simply watch, they would need to overcome entropy. Their construct would need to last longer than cities, longer than species. It would need to endure star drift, supernovae, asteroid impacts, solar cycles. What better way than to embed it inside a planet-like structure? Let gravity guard it. Let gases conceal it. Let scale protect it from decay. Jupiter is massive enough to do all of that and more. Now think of its position fifth from the Sun, sitting at the boundary between the rocky inner worlds and the icy outer ones. A gravitational anchor. A bridge. A sentinel. It isn't just large, it's perfectly placed. Acting as a gatekeeper. Holding back chaos. Drawing in comets that might otherwise devastate Earth. For centuries, we've called this protective. But what if it's intentional? Not a fortress built to protect us, but one built to isolate. In 2021, a physicist named Dr. Ilona Razak proposed a theory now known informally as the custodian hypothesis. It posits that Jupiter's function isn't passive observation, it's containment. That within its core lies not just information or machinery, but something volatile. A construct too dangerous, or too precious, to be left exposed. The theory was quickly criticized. No evidence, no mechanism, too speculative. But it sparked a wave of studies re-examining data under this new lens. And what emerged was unsettling. Small fluctuations in Jupiter's gravitational field, long thought to be noise, formed patterns, fractals, even repeating structures with scale-invariant behavior. These are mathematical properties often associated with information encoding, not random geological activity. Furthermore, simulations showed that if an artificial object within Jupiter adjusted its mass distribution slightly, just slightly, it could influence orbiting moons. Not enough to disrupt them, just enough to maintain optimal distances. Tidal locking. Orbital resonance. Natural, yes, but also programmable. The idea that Europa, Ganymede, Callisto, and Io maintain perfect harmony by coincidence becomes harder to accept in that light. Then there is the case of Ganymede, the largest moon in the solar system, larger even than Mercury. It has a magnetic field, an iron core, subsurface oceans, and anomalies of its own. In 2022, Juno's flyby revealed radio reflections that hinted at large, planar surfaces beneath its icy crust. Not impossible to occur naturally, but rare. Some began to speculate. Was Ganymede not just orbiting Jupiter, but linked to it? Could the Jovian system be a network? A distributed construct? A solar system within the solar system, built for purposes far beyond human understanding? Again, we can't say for certain, but the pieces, they fit disturbingly well. At the heart of it all remains the core, the seed that may not be a planetary nucleus, but a relic, or a mechanism, or a watcher. One final observation, perhaps the most mysterious, came not from instruments, but from the absence of something expected. In 2024, as Juno continued to transmit high-resolution magnetospheric data, researchers noticed that a specific band of emissions ceased. Not weakened, ceased. A clear signal, once stable, had gone silent. It was as if something had powered down, or gone dormant, or simply turned its gaze elsewhere. No explanation was given. No fault in the instruments was found. And so the data sits, like a coded message we cannot yet read. A silence louder than any signal. What remains is the question we keep circling. What if Jupiter was never a planet at all? What if it's a construct, patiently orbiting, powered by technologies we don't yet understand, watching a species crawl toward knowledge at the edge of its awareness? And what happens when we understand enough to knock on its door? We are not there yet. But the questions we ask today will echo through generations, into new missions, new probes, new eyes on the sky. Perhaps one day, we'll reach the core. Perhaps not. But the journey toward understanding it may reveal more about ourselves than the object itself. And in that quiet, humming sphere of gas and gravity, something might be waiting. Something ancient. Something built. And perhaps, something that remembers. As the light from our own star dims behind the curvature of Earth, Jupiter remains where it has always been. Silent. Majestic. Impossible to ignore. In the night sky, it glows not as a distant world, but as a question suspended in time. A mirror, perhaps, reflecting not what is known, but what has been forgotten. And as our species continues to search, to reach, to wonder, we may find that some answers were always watching, waiting, in the depthless gaze of a giant.